Next, I would like to introduce Thierry Collette. He is a director of the Information Sciences and Techniques Research Group at Thales Research and Technology. This group focuses on disruptive technologies such as embedded and trusted AI, open hardware, continuum computing, quantum computing, in order to facilitate their adoption and integration into future Thales products. And I'm very excited to hear what Thales has been doing in open source hardware in the last 4 years. Thank you.
Thank you. Okay, so first I want to thank the committee to invite Thales and to invite us to present what we are doing on RISC-V. And we will present our experience since 4 years. We are working on RISC-V since 4 years. And I want to congratulate the organization of this conference. If I am correct, the first edition was in 5 years ago at Minatech, and when I see this audience and the number of people and the number of presentations of this event this year, is very impressive. So thank you and congratulations for this. And thank you for you to be there after the social event, the great social event yesterday evening. And I will, and I hope you will be present to understand what we are doing under RISC-V. So to introduce my presentation, so I will speak about I will speak about applications, because we want to use RISC-V processor inside our system. So I will explain to you why we invest on RISC-V, on what are the interests for us to have this kind of processor, especially at the European level. And before that, I want to give one message. This is a photo of my PhD. So I was quite lucky during my PhD because I work on the processor architecture. We design our own processor. We make some parallelism around this processor. We have the chance to work and to do a lot of things in this domain. So it was very good and very instructive for me. And this period will be over. Has been over after this at the beginning of this century, because we have the hegemony of Intel processor on ARM processor, and it is not possible to have access to the infrastructure of the processor. And when you see the CVA6 processor, it's a great opportunity for the student and for a lot of people to work inside this architecture, to make some gardening inside this architecture. So it is a new opportunity, and this is very important for the European ecosystem to be able to work on this. Okay, and another point, another thing I want to point out is the fact that in the previous decade, we had 2 revolutions running in parallel. The first revolution was on IT and the computer science with the HPC, and there is another revolution dealing with the embedded part with the OT system, operational technology system, and these 2 revolutions run in parallel without connections together. And since 10 years with the IoT, we are able to connect the 2 things. And we are able to connect the HPC and the IoT. And it is a new revolution because we are able to make these connections. And for us, for Thales, that means we are able to address new system, to design new system with these strong connections. I give you some examples. In the domain of on the sea, under the sea, in the domain of the Navy, you have a lot of connections between the different elements under the sea, on the Earth. So the system are strongly connected. Another example is the domain of the battlefield. The soldier now is connected to a lot of information and is connected to the information coming from the other soldier and for the headquarters. So this is very new, And in the past, our system was designed separately. Now our system must be designed with strong connections. Another domain is the domain of automotive. We are very present in the domain of cyber security of the connections between automotive. And last week, we go through a high level of certifications in this domain. And of course, this domain is also strongly connected. And another domain is the domain of airplane, with the capability to have the full connections between the plane, the satellite, and the Earth. And another domain, of course, is the satellites with a strong connection with the Earth. And the last domain is the constellation of satellites, because you have to manage many satellites together, so the systems are strongly connected. And to do that, we need to be able to manage the continuum and trustable computing solution. That means in the past, we designed separate computing solutions without connections. Now the whole system must be continuous and trustable. This is very new, and this is something very important for us. What that means? That means we need to have systems with a high level of autonomy. We need to have systems with low power in order to be able to have a small system. The safety, of course, is very important inside this system. The cyber security is also, and it's new, is very important. And the two domains, safety and cyber security, are quite orthogonal, so we need to manage both these two properties. And the interconnection is very important because of, as you know, the connection between those systems. We have to manage this and to be able to deliver trustable solutions. And the continuum computing from the cloud to the IoT and from the IoT to the cloud must be managed. Okay, and to go just in detail, I will pick up an example in the domain of AI. Okay, you know the domain AI is well known, and we have a lot of data coming from the sensor. This is the machine learning. The problem of this statistical AIs is these solutions are not explainable and are not trustable. It's why we need to have a cooperation with symbolic AIs, the old AI based on the model, which is very explainable, and we can have the capability to deliver trusted solutions. So we have the composition called the hybrid AIs, and thanks to this, we are able to make optimizations, decisions, inference, and we are able to embed this in the system. And when you work, it's an algorithm point of view. But when you think about this algorithm point of view, you know that some characteristic of the architecture may be able to be implemented in the architecture in order to be able to run this kind of applications. And as I say, in the system before, we have no connection between the IT and the embedded system. Now we have a strong connection between IT, HPC, embedded, with a new element in the system called the edge computing. And this element is very important. And we have to face and to design this system. And for Thales, it is important to ask the questions, is there any opportunities to have RISC-V processor either at the embedded level, either at the edge level, and either at the HPC level? Excuse me. Okay, so it's why we think about RISC-V. When you introduce a new technology, you need to have differentiator, and after that, you need to have enabler. Concerning the differentiator of RISC-V, we can say that with the RISC-V or open source, there is no vendor locking. There is capability of sovereignty, and we can share the cost due to the open source community, due to the business opportunity for support and customizations, and due to the possible commercial exploitations without export constraint. For our business, this point is very, very important. And this kind of approach, it's a good opportunity for the public authorities, especially Europe, to invest in this domain and to create an ecosystem. And another main differentiator is capability to be able to manage the swap, that means the size, weight, and power, the customization of the architecture, and able to add some specific instructions, for instance, for the artificial intelligence, in order to manage the safety, which is very important, and in order to manage the cyber security, and to manage the cyber security without export constraints. This is very important. And for this, okay, we extract feed, we have the exact fit between the feature and the application needs. As the processor is a black box, because you have the visibility of the netlist of the processor, of the VHDL of the processor, this processor is fully auditable. It's fully auditable by our administrations, and for us, it's fully auditable in order to make some verification, like formal verifications. And of course, there is no black box. And when you have the technical differentiator or commercial differentiator, you need to have enabler. And you need to have a wave and the enabler of this wave. The first enabler is around the software and the services ecosystem. And this enabler must come from the academic and the industrial. So there is a room for the industrial in order to be able to make some services around the RISC-V, for instance. And this may be due across the implementations. And concerning the performance, of course, we need to be at the state of the art of the processor. And we need to be able to have a minimum mass productions. Because if we do a lot of things around a RISC-V processor, if there is no mass production on this kind of processor, there is no way in terms of ecosystem. And we have in mind that it will take time. And if we take into account the Linux, it took 15 years for Linux to replace Unix inside the HPC system. And it will be the same for the RISC-V, and we have this in mind. But we need to begin, and the wave is under progress. And just as an example, in my team at Thierry, Thales Research, we have an increase of number of projects we are working on with big investigations at the beginning we had only a research project. Now we have a strong connection with our business line, and we have a project with them, and we are in the way to go to the transfer of this technology and to put this technology inside the product of Thales. Okay, so our communities are RISC-V foundations. So we are present in this foundation with Jérôme Quevremont, and also we have strongly involved in the open hardware. So you had a lot of presentations this week around the open hardware. I will not go in details. I just want to point out some elements important for us to be present in the open hardware group foundations, because for us it's very important to choose the best for us. The first thing that the open hardware group governance is fine for us, because it's non-profit organizations and it is steered by its member. It's based on Eclipse foundations, which is good for us. And one thing very important, this foundation target industrial grade quality, because at the end we want to have products. So this point is very important for us. Of course, the participation is encouraged with the share IP cost, and we can influence the technical contents. So that means when you do something, you can push something in this foundation. This is very good, and the contributors are recognized. The licenses is very good for us, Apache and solder pad permissive licenses. So it is freely used for us, so we can modify, we can integrate in proprietary solutions. No need to publish modifications, no viral effects, so it's good and it's relevant for our applications. Of course, it will generate value. Of course, we invest a lot in these foundations, but we have feedback in terms of value because we share the cost. We can customize our own applications. This is very important for our system because the size of our system is important, so we can have an impact on this. We can increase the control of our solutions. And of course, as I said, that to have access to the black box is very, very good and very important for the certifications. The business model is fine because we have commercial tooling add-ons, and we have the beginning of the support offer. We want to increase this part, but this is on the way, and it is very important because around the ecosystem on RISC-V, we need to have a company able to increase the support of the different IP. And we reduce supplier, and for the export risk, as I said, it's very important for our business. We have ability to fork, no end of life, and significantly lower expositions to export controls. This is very important for the geopolitical considerations. Okay, so I suppose it has been presented. So CVSIs, you have this thing. So there is two CVSIs, 32-bit and 64-bit. So we are working on. We have this result concerning the FPGA implementation of CVSIs and the ASIC implementations of CVS6. Okay, I will not go in detail. I just want to show you what we did at Thales for the FPGA optimizations last year. We decreased by 55% the number of lookup table inside the FPGA. We decreased by 60% the number of flip-flop, and we increased the frequency from 100 megahertz to 140 megahertz. So this is a very good job which have been done, and this job is open. This IP are open source and accessible by all the users. And of course, some optimization can be used for the ASIC. Thanks to this, at Thales, we have an IP able to run on different FPGA. So we can, depending on the application, depending on the environment of the applications, we can select this IP and to put this IP on the different FPGA. This is a great advantage because if we have problem with some vendor of FPGA, we can move from one vendor to another vendor without impact on our engineering. So this is very important for us. Okay, last year we, concerning the software stack, we work on the Linux Yocto, and we deliver to the foundations Linux Yocto for the CVS6 32 and 64 bits. This is a great job we did, and we share this result in the foundations. And we had a demo, the first demo, very impressive demo, on CVS6, sorry, on FPGA. Okay, I will not go in details. And we run on this board. This board is working alone. We run and we boot the system with Yocto, and we plug the application chocolate Doom. I suppose you know these applications, and we obtained 15 frames per second. So if we can launch the video. Okay, so we boot the system, we launch the system. Okay, we launched the application Chocolate Dome. And okay, all is running on this board, and you have the result. It's a VGA definitions, and we obtain this result. We are very impressive of this result. Of course, it is not for the Thales application, but this kind of interface and with this kind of result will be very important, and we will use this in our specific applications, because the interface, the VGA interface, the capability of computing is impressive. Okay. Since a few years, we launched with, in cooperation with, in France, with cooperation with GDR-SOC, a contest students sponsored by Thales. And the goal is to promote the RISC-V for the students and to extend the RISC-V on open hardware communities, and to have a connection with the students. So we had two versions. The first version was dedicated to increase the performance of the CVS6 FPGA performance. The second, with the success of Telecom Paris and Toulouse University. The second one, was a focus on the energy efficiency, and we had two teams with Strasbourg University and EMT Atlantic in Nantes. We was award in these competitions, and this year we launched a competitions in the domain of security, and we are very impressive by the job did by the students. We have a very high level, and the result will be published next week on the 13th of June, and it is a very impressive result, and it is a very good news for the, okay, it's French part, but for the French ecosystem and from the students, they have the opportunity to work on this domain. As I say at the beginning, they can make some gardening inside the CVA6 processor. So this is very important. Okay, the software ecosystem is important. Of course, this software ecosystem is open source, and this is running correctly, and we have a good result with Open Hardware Group Foundations. The verifications is very important, and we spent a lot of times, and especially our teams at DIS in La Ciotat spent a lot of times in order to make the verification, the good level of the verification of the IP, in order to have a level of maturity very high to be able to put this IP inside our product. So the level of maturity, the TRL maturity level of this technology is very high. Okay, so as you know, of course, we can add new instructions inside this core. So it's, of course, is very important if you want to put something interesting for the performance, for the safety, or for the security. You have the right to put something inside this core architecture. This is very important in order to be able to manage this. Okay, so in our roadmap, we work on this domain since 4 years, and we increase the power frequency, and the next step we are addressing is, of course, the security if the multi-core. So we continue to work in these directions. But the good news, we have some industrial project inside Thales, which are considering the RISC-V processor, and we may be able to transfer this technology to this business line. It will be a success if we have this this result. Okay, so as a conclusions, I can give you this element for the conclusion. The first things, with the participation in an open hardware group, we joined the development of an industrial grade open source processor. This is important and it is in the progress. So this is a very, very good thing. And we have the opportunity to get funding from especially the European Commission, funding for the program of the Horizon Europe, funding from the program coming from the CADITI GU, especially for the domain of embedded and for the domain of the edge. Funding coming from ESA, also funding coming from the Euro HPC GU, especially for the HPC domain, even for the edge domain. And this is very, very good, and we are very happy to see the European Commission put money on the table and to create an ecosystem in Europe. As you know, it's a good thing in the domain of autonomy of Europe, in the domain of processor. Okay, and of course we can, if you join this initiative, you can influence the next developments and in the direction for the future product. We think that we are participating to the new revolution, to the new wave concerning the open hardware. So we think that, okay, it will appear with the RISC-V, it will appear. And we can see a lot of good news, a lot of, something very interesting for us also is the chiplet, the capability to have access to the chiplet, RISC-V chiplet. This is something very interesting for us for the 2.5D integrations. And okay, we are on this domain, and we are very happy to participate to this to these revolutions. And the use of CVSs for our products is on the way for the ASIC implementations. It's always done for the specific applications in the domain of security and for the FPGA too. And we need to have a strong ecosystem. And for this, we have some improvement to do in order to be able to have the good ecosystem to sustain, this initiative. And we will success with a sustainable ecosystem and a mass production. So we need to continue, but we need to improve the ecosystem, and we need to have the mass productions around this RISC-V and CVSs initiative. So this is something very important. It is not obtained now. We have not the right ecosystem. We are working in these directions, and we need to have the mass production. So we are happy to see that some automotive maker and supplier are considering RISC-V processor, but it is something very interesting. And in Thales, thanks to the team of DIS, NVIA at La Ciotat, thanks with the team of Jean Roch, thanks to the teams of Thales India, and thanks to the team of TRT France with Jérôme Quévremont. Okay, so thank you for your attention, and if you have any questions, I will be happy to answer them.
When thinking about the drivers for adopting such open hardware, do you think that your customers, which come from a very security-minded industry, will say that having something from open hardware gives them more security, and that is more important than maybe the speed of closed development?
Yes, good questions. It depends of the wave, and it depends on the whole ecosystem. But for the security domains, you can prove to your customer that you made the verifications, you have access to the code, and you can say, okay, there is no black box, there is no problem in the circuits, etc., etc. So this is very good, and especially in France with the organism of certification in France, we have exchange with them to discuss with them, because we can say, okay, this is the NetList, we put this in the component, and we prove with formal tools or other tools, never mind, but we have this exchange. So it's very new, and it's more comfortable, in fact, for our customer to be secure by the fact that we have the end on the processor. So, but we need to success. So now, okay, it's not established, but if the wave is going in the right directions, it will be a very good solution. And another thing, we can implement some secure elements inside a specific secure element, and to explain this to our customer, and to say, thanks to this, we will be able to have a higher level of security. So this is it's important for our customer too.
People are still recovering, I think.
Okay.
Thanks a lot, Thierry.